Hello everyone! Finally, we will talk about modifications for Tilta Float System, after which it will be more easy and pleasant to work with this system. Let's go, step by step. I've previously discussed the issues with West support in one of my videos, be sure to check it out if you haven't already. After some time using shoulder support along with West support, I realized that the West lacked rigidity, causing the system to distribute the loadout incorrectly during operation. Additionally, I couldn't find the right position for the lower back support, as it created significant discomfort in the lower back during work. Sometimes my muscles even cramped, making it impossible to continue working. So I decided to reinforce the entire structure, raise the lower back support slightly above the shoulder blades. This way, in my experience, I significantly reduce the load on the back during work, and in this position the lower back support prevents the system from tilting forward. For assembly, I used 3 plates, 2 of which were included, and the third I already had, and I will leave a link to similar one. We will also need a few bolts. The assembly process is simple, connect all the plates one by one and tighten them well. I started from the bottom up to make it easy to adjust the height I needed. The vest attaches to the original locations, 2 in front, 2 in the back. However, attaching it to the back plate was only possible using plastic ties. Yes, it's not the best option, but there's simply no space for any other attachment, and I didn't want to drill holes in it. The additional strap that came with it is unlikely to keep it in place, as the attachment area is very small. But even with this attachment, it remains stationary and successfully fulfills its purpose. After several projects, nothing broke or came loose. In the future, I might come up with more reliable attachment. You can also add a quick release belt around the waist for additional safety. It will prevent the system from failing if vest comes unfastened during work. I must say right away that the author of subsequent improvements is Vahamed. At least on his channel I was learned about these modifications, and I want to thank him. The first modification concerns the upper mount. It needs to be rotated 90 degrees to have the ability to adjust the gimbal balance left or right. The thing is that initially the mount can only be adjusted forward or backward. But if you balance your gimbal correctly, the center of gravity will always be in the middle of mounting points. So the forward-backward adjustment doesn't matter much. To prevent the system from failing forth or back, we can adjust the position of the batteries. However, we can't prevent the system from tilting and rotating to the right or left with a standard mount, which is why we need to rotate the plate by 90 degrees. Rotating the mounting points by 90 degrees is very simple if you have the right set of tools. We need to unscrew 4 bottom bolts and the platform easily comes off and can be rotated. You can adjust the lock position if needed. You can choose the lock position yourself. I place it in the front. We will also need a quick release Manfrotto plate and nano rail. I've got the same what I saw in the video of Vahamed. However, I faced some issues with installing the calm weight nano rail. The thing is that it didn't fit initially, so I had to use sandpaper to remove the top layer from both sides to make it fit. I also had to adjust the position of lock tongue, as otherwise it was impossible to tighten it. Now it works great, goes in, comes out and locks. To install the quick release plate, I had to make some significant modifications. Firstly, I had to drill a hole for quarter bolt on one side. For some reason, nice rig made asymmetric holes. If the bolt fits without any problems on one side, it simply doesn't on the other side. Secondly, I use adapters for 3x8 to quarter bolts to secure the plate right in the middle of nano rail. Otherwise, the nano rail itself will be offset to the left or right, which I didn't like. Plus, if you screw the plate and nano rail without adapters, it will be impossible to install it due to the lack of height. I secured the plate with two 3x8 bolts. By the way, it sits right in the middle of our center of gravity line, which means our balance should be maintained. The second modification is related to the mount battery mount. We need to create a pendulum to make the whole system more stable, allowing us to work in both horizontal and vertical positions. I also took the Vahomet video as a basis, where he shows in detail how to assemble such system. However, I decided to create my own DIY mount from what I had on hand, leaving as many original components as possible. The entire structure will be held by included cross nano rail. I had to disassemble it and shift it to very edge because in my setup I lacked the length for balancing the system. By disassembling the old handle from the monitor mount, I got an excellent mount for nano rail mount. By cutting another mount, I got two mounts for 15mm rails, which I attached to the base plate. Now we can install one 50mm rail, then add several locking rings to keep our battery from shifting. I used regular plumbing rubber rings as locking rings, size 8. As for the battery mounts, instead of large V-mount plates, I decided to use their mini version. I attached 50mm throat adapters to them. Now let's connect these two parts together. To do this, place both batteries in their position. This is necessary to set the 15mm rail symmetrically relative to each other because the tubes will be simply dumped into the base of batteries, and I will be able to tighten them freely. Our Pendulum battery setup is ready for use. Thanks to the platform from quick release plate, the gimbal can stand on the table without tilting, which made it much more convenient to work with. Moreover, the quick release plate allows for quickly removing or reattaching it to the post, a feature not present in the original version. Make sure to install the side mount for safety before placing the gimbal on the post. If you're balancing the entire system for the first time, set everything to a neutral position, right in the middle. This will be your starting point for balancing. Now let's align the post horizontally by shifting the center of gravity forward or backward, depending on the direction the post tilts. We need to ensure the post remains as level as possible horizontally. Also check the system in a horizontal position to ensure it doesn't lean left or right. Well, it looks good. Now let's check the center of gravity of our gimbal. To do this, transition the post into a vertical position and hold it so that it doesn't tilt forward or backward. Let's release it and see what happens. If the post turns to the left or right and then tilts, it means the gimbal's center of gravity is shifted to the left or right from the top. To fix this, we will use our first modification and move the gimbal slightly to the left or right. I don't touch the rail itself, it's much easier and more convenient to use the platform. Achieve a position where the gimbal doesn't turn or tilt to one side. Great. Now I can balance the vertical position of the system. Let's release it and see what happens. In my case, the system tilts forward, so I move the batteries backward. We do the same if the post leans left or right, shifting the batteries in the opposite direction, favorably balancing the system. Now with post able to maintain its vertical position, I can check the balance of the entire system. Let's give it a gentle push. It should smoothly rise or descend without drifting anywhere. Yes, everything is great. I'm quite satisfied with the result. That's all for today. Write your opinion in the comments and see you in the next one. Bye!